Hope you're doing well. I'm going to give you a quick little review of the real number system, and hopefully, this will help you with your rational and irrational. So, real number system is the biggest number system that we have, and it's broken into two categories: rational and irrational. Rational numbers, that's something that you should be very familiar with. That's the math that you use ever since you're like a little kid. Like if you were counting Cheerios or if you were taking steps. And that's our counting numbers. So anything that you can count is a rational number based upon the fact that it's also a counting number. So from the counting numbers, you also have the whole numbers, and that's all the counting numbers in zero. And then you have the integers, which are all the whole numbers, and then their opposites or their negatives. So these are always going to be rational. And the main reason we consider them rational is that they have exact values, or they can be written as fractions. So if I had the number 3 and I wanted to write it as a fraction, I would just put it over 1, make the denominator 1. Okay? Now, decimals, it does get a little tricky with decimals, but any repeating decimal or terminating decimal is considered rational. So a repeating decimal will be something that has like 1, 2, 1, 2, 1, 2, dot, dot, dot. So I could technically write that as 1, 2 at the bar, and that would make it rational. Okay, a terminating decimal, that's easy to see that it's rational. Say I had 0.35, because that's the same as 35 over 100, which makes it a fraction. And fractions are always rational when they have integers in the numerator and the denominator. So we say a over b as long as a and b are integers, but b does not equal 0. Okay, so what's irrational? Irrational is all that strange stuff like pi or the square root of 2. It's things that do not have an exact value unless they're in a symbolic form. So we say that these are non-terminating, non-repeating, cannot be expressed as a fraction or as a ratio in the form of a over b, where both a and b are integers and b doesn't equal 0. Okay, so let's just look at some more formal definitions, okay? So here's the formal definition of irrational. Any real number that cannot be represented as an exact ratio. The decimal form of the number never repeats. Terminating repeats with a 0, so we consider that also repeating. Now here, this is the definition of rational. Any number that can be expressed as a ratio in the form a over b, where a and b are integers and b doesn't equal 0. In a fraction, 2/3 all cool, 2 over 0 not cool. You can never have 0 in the denominator of a fraction. Okay, counting numbers, whole numbers, integers, fractions, repeating and terminating decimals are all considered rational. Okay, so which of these numbers is rational? Well, 5/4, because it's written as a ratio where the numerator and the denominator are both integers. Which number is rational? Well, this is going to take a little work, but it's going to be choice 3, because the square root of 9 is equal to 3. So what that is really saying is 5 times 3, which is 15. And 15 is a counting number, which makes it rational. Which number is rational? Same idea. Now that's when you want to look for anything that is a perfect square. If you find the square root of a perfect square, it's going to be an integer. That's why it's going to be choice 4, because the square root of 1 is 1 and the square root of 4 is 2, which makes that the fraction 1/2. Okay. Which is an irrational number? Well, we already said that the square root of 9 is 3, and 3 is a counting number, so that's rational. 3.14, that's a terminating decimal, so that's rational. It's going to be the square root of 3. If you type that in the calculator, it will stop, but only because the calculator display ran out of room, not because the actual decimal terminated. And we know 3/4 is a ratio, which is irrational. Pi is the most famous one. Pi starts with 3.1415, but it doesn't stop. Can't stop it, therefore irrational. Okay, so this one's, they're trying to trick you because there is a pattern, but a pattern is not repeating. It's just a pattern. They're different things. So this is going to be irrational. Okay, well, I hope that helps a little bit. If you have any more questions, please feel free to reach out, and I hope you're having a great day.